Hey everyone, welcome back. Ready for another deep dive? Today we're going somewhere pretty interesting. We're going to be talking all about electromagnetic shielding.
Okay, so what is electromagnetic shielding? I mean, I think I have a pretty good idea, but
Oh yeah, great question. Electromagnetic shielding. Well, let's imagine you have a material that can block electromagnetic interference.
yeah.
Now, this is super important, right? It's crucial for a lot of things we use every day. Electronics, aerospace, even industrial equipment.
Hmm, interesting. So, where does today's deep dive take us?
So we're going to be looking at a specific company and the challenges they faced. They were actually working on a really unique material. It was an epoxy-ceramic composite for electromagnetic shielding.
So, it was a company that was pushing the boundaries of material science. Huh, I like that. I like where this is going.
Yeah, and the thing is, they needed a way to test this material.
Of course, of course. I mean, every new material needs to be tested, right?
Right. But it wasn't so simple. They needed a very specific testing setup.
Ah, I see. So that's where the challenge comes in.
It does. Because, see, standard testing setups, they often don't work with unusual shapes or sizes. And, accuracy is key here,
Yeah,
right?
absolutely. Absolutely. Reliability is paramount for results. You can't just wing it with this type of testing.
Exactly. So they needed to find a specialized vendor, someone who really knew their stuff.
I bet that wasn't easy, finding someone with the right expertise for a custom setup.
It wasn't. But they found a company called Infinita Lab, and they really had the know-how to pull this off.
Infinita Lab. Okay.
Yeah.
What was it that made them the perfect fit for this challenge?
Well, they were able to not only provide that custom testing setup, but also make sure that the whole process followed a specific standard, i.e. STD 299.
Ah, IESTD 299, the gold standard in the world of shielding effectiveness.
That's the one. So you can see how Infinita Lab played a huge role here. They made sure the testing was rigorous. It really followed those industry standards.
It's all about accuracy, right? I mean, if you don't have accurate testing, the data is useless.
Right. And the good news is the company got great data from this whole process, proving that their material met those standards.
So a success story, it sounds like it. A testament to finding the right partner for the job, I'd say. But I'm curious, what was so unique about their material? I mean, you mentioned epoxy-ceramic composite earlier.
Yeah, well, it's a fascinating choice, right?
Yeah.
Epoxy is known for being strong and flexible, and then you have ceramic, which is an excellent electrical insulator.
Hmm. Yeah, you don't hear that pairing every day. What were they going for with that combination?
So it turns out they were developing this composite for a very high-frequency application. It needed to block out interference in a very specific, very challenging range of the electromagnetic spectrum.
So that's why they needed that custom setup. Standard tests just wouldn't cut it for a material this specialized.
Exactly. They had to be absolutely sure that this material could really perform under those specific conditions.
So it wasn't just about blocking interference. It was about doing it under very particular circumstances.
You got it.
And with a level of precision dictated by IESTD 299, that's no walk in the park. It's quite a challenge for Infinita Lab, I'd imagine.
Oh, absolutely. I mean, just think about some of the challenges Infinita Lab had to deal with. For example, they had to think about the actual frequencies involved.
Right, those high frequencies are no joke. You need extremely precise equipment to generate and measure them.
Right. And then you've got the power levels to consider. They needed to replicate real-world conditions. So they had to make sure the equipment could handle that power without adding its own interference.
It's a very fine line to walk, a very impressive feat. So, with all these hurdles, were they able to deliver? Did Infinita Lab pull it off?
Oh, they did. They provided the company with the reliable data it needed.
Data they could trust, data that met those rigorous industry standards. I am curious, though, what was the outcome? Did the material perform as expected?
Yeah, that's the best part. The results were conclusive. The epoxy ceramic composite. It met and, in some cases, even exceeded the shielding effectiveness needed for the application.
Wow. So their innovative material actually lived up to its promise.
Absolutely. And remember, all of this was verified according to that industry standard, i.e. STD 299.
They had the data to back it up. That's great. What a fantastic example of how important specialized testing is in this field.
It is, right. Without it, who knows? They might have been left in the dark, unsure if their creation was truly as effective as they thought it was.
It highlights the crucial role of testing in material development, but it also makes you think about what's next.
What's next? Yeah.
What if we could push even further? I mean, imagine creating shielding materials that were even lighter, more flexible, even more effective.
That's a great thought.
Think about the possibilities. We could have even more efficient electronics, smaller devices, maybe even new medical technologies we haven't even thought of yet.
It's pretty amazing to think about. So, to everyone listening, I'm curious, what innovations in material science are you excited about, and what applications can you envision for these advanced materials? It's something to think about.
Absolutely. Thanks for joining us on this deep dive.